Hey guys, welcome back to the channel. Today we're going to be solving Leetcode 190 reverse bits. Okay, feel free to pause the video just to read through what the problem is asking for, but I find the examples more descriptive. So given a 32, again 32 is the keyword, 32-bit number, binary number, okay, we want to return the reversed version of him, again in decimal. So if you take this number and you reverse it, reverse all the bits, meaning the last bit becomes the first bit, second to last bit becomes second bit, third to the last bit becomes third bit, and on. We want to return that. Okay, so there's different ways to approach this problem. Okay, the first way, which to be honest happens to be my favorite, create a list. I'm just going to call it lists representation. Okay, set it equal to, okay, I'm creating a list. Okay, lis list, creating a list. Okay, now here's the meat and potatoes of this. Okay, there's a dot format. Okay, I want to reformat n, okay, which is my input, which is the number we're given. Okay, but how do I want to format him? Here's where the trick comes in. Okay, pair of curly braces, colon 032 b. So I'm just asking for, hey, take n and format him into a string of 32 bits, binary. Okay, so once I get the string, I convert it to a list, and then we have the reverse method we can use on the list. So we can just say, let's reverse him in place. Okay, we just say a list rep dot reverse. So this way we don't have to create a new variable, we just reverse him in place. Okay, now what do we want to return? Okay, we want to join him back. Python has the join method that takes in a list and joins the elements of the list. Okay, so what do we want to join? We want to join our list. Okay, but that's not enough, right? We're expecting a number, we're expecting to return a number, so we want to typecast it to integer. Okay, we want to join him to, okay, base 2 integer. Okay, I hope this makes sense. This looks correct. I'm gonna go ahead and run code and see what happens. Okay, accepted. Let's go ahead and submit it. Okay, boom. Oh, this is awesome. This is -7% fast and speed. Okay, so let's go ahead and take a snapshot of this just to keep track of how we're doing. Okay, so this is one way to do it. Okay, there's a second way to be honest, this way is more straightforward to me, but second way, which is what I believe they're actually asking for, to use a more bitwise approach. Okay, and let's see how that works. Okay, so first I'm gonna create a variable called output, which is gonna store my output obviously, and I'll create a second variable called bitplace. Bitplace is gonna, so output is gonna be initialized to 0. Bitplace is going to be 31. The only reason why it's 31 is because we were requested for 32 bits. Okay, 32 bits is the reason why it's set to 31, because strings and arrays are 0 based. Okay, so once we have that, the next step is a while loop. Okay, while our n is not 0, what do we want to do? We want to increment our output. So what do we want to increment him by? Output plus equal n, which is the number we're given, and 1. We're going to end it with 1, and I'll show you what the ending with 1 does. But ending with 1 just retrieves the last bits of whatever n is, because 1 is 0 0 0 0, 31 zeros, then 1, right? So and with n, everything else is going to become 0 except for the last bit of n. So we're going to take that. Okay, I'm going to shift him, I'm going to left shift him by bit place. Okay, and again, you're going to see what's going on later. So once we left shift him by bit place, now we want to right shift n to pop out that last bit. Since we retrieved the last bit here, we want to take him out. So we're going to say and we're going to right shift him and set that by 1. Okay, and we're going to subtract 1 from bit place. Okay, so and then once we're done with the while loop, we're going to go ahead and return output. Okay, so this looks correct. Let's go ahead and run code just to test it out and see what's going on. Okay, accepted. Let's go ahead and submit it just to, kind of check it out. You know what I'm saying? Okay, so this is not as fast, but in terms of memory, it's much better. So let's compare these two. It's not as fast, but in terms of memory, it's much better, as you can see. So now to explain what's actually going on with this implementation we just did. Okay, this is the same implementation we just did on Leetcode, but I just want to walk you guys through what's actually going on. Okay, let's go back to the description. Okay, so for instance, let's say our n equals 3. Okay, 3 in decimal. If you convert this to binary, okay, to binary, it's just 0, 1, 1. Okay, this is our n, 0, 1, 1. Now, in the first iteration of our while loop, okay, this is iteration number 1 of our while loop. What's going to happen? Obviously, our n is 3. So I'm just going to write the binary representation. N is 0, 1, 1, 3. Okay. Bit place is going to be, obviously, since this is just a 3-bit number, bit place is going to be 2. So let me just write that. It's going to be 2. Okay, so bit place, it's going to be 2. Okay, what else do we need? Okay, and output, since we initialize it to 0, it's going to start us at 0. Okay, in our first iteration of the while loop, okay, output is going to become, okay, just like the formula, he's going to be our previous output, which is 0, plus, okay, n is 0, 1, 1, 3, and n and 1 is just 0, 0, 1, binary representation. And then we're going to have to left shift this guy by 2 because bit place is 2. Okay, this is going to look something like this. It's going to be 0 plus, okay, once you end this 2, it's just going to take our last bit like we said, because 0 and 0 is 0, 1 and 0 is 0, so this is going to give us 0, 0, 1. Okay, now we still have to left shift him by 2, right? So this is just going to be 0 plus 0. So if we left shift him by 2, 1, 2, so plus 100, which is 4, binary 100 is 4 in decimal, so this just gives us 100. Okay, this becomes our new n. Okay, so now we go into our second iteration. Okay, oh, so this becomes our new n. Okay, this is n. Actually, that's not n, that's our output. Okay, so n again says we're gonna right shift n by 1. Okay, so what was n before? N was 0, 1, 1. So if we right shift him by 1, n becomes 0, 0, 1. Okay, this is our new n. Our previous n was this. We right shift him, and then we're gonna also have to right shift bit place. Actually, not right shift. We're gonna have to subtract 1 from him. Bit place was 2. He's now 1. Okay, so in our second iteration of the while loop, okay, this is what it's gonna look like. Okay, and again, let's just write it over again. Is 0, 0, 1. Again, we got it from right here. We solved it. Okay, bit place is gonna be 1. Again, we get it right here. And output is gonna be 4, which is 100 binary. Again, we're gonna solve for our output again. Output is just simply equals to our previous output. Again, 100 was our previous output, plus, okay, n. What is n? N is 0, 0, 1, and then with 1, 0, 0, 1. Again, we're just getting from this formula right here. Okay, then we're gonna left shift him by bit place. Bit place is what? Bit place is 1. Okay, so this is just equal to 100 plus. Okay, once you end these two guys, it's just gonna be 0, 0, 1. Okay, then we want to left shift him by 1. So this is just 100 plus 0, 1, 0. Okay, because we left shifted him by 1. So this is gonna give us 1, 1, 0. Okay, this is our output. So now let's calculate our n. N is just gonna be previous n, which is 0, 1, 0, right shifted by 1. We're right shifting by 1. So it's just gonna be 0, 0, 0. N is 0, 0, 0. Okay, and bit place is just gonna be our previous bit place 1 minus 1. It's gonna be 0. So at this point, since n is 0, our while loop would not execute, right? Because it says while n. So n is 0, our while loop is not going to execute, okay? Meaning we've come to the end of this. And now we want to return output. So our output we're going to return is just 1, 1, 0, okay? This is our return value. Keep in mind, we started our input n started off as 1, 0, 1, 1. So this was n initially. This is our output. And as you can tell, this guy is the reversed version of this guy. That's it for the video. I hope it was clear to help you guys kind of understand what's going on. It was a really good problem, and I'll see you in the next one. Thank you.